Welcome to Day 5 of GoDataFest 2020. GoDataFest is a 5-day event celebrating everything in data technology. I'm your host Jasper Gin, and today is all about open source. I'm pleased to be joined today by Jurjen Helmus as my co-host. Welcome.
Thank you so much.
Jurjen is a researcher at the Amsterdam University of Applied Sciences, and he is also the coordinator of the Smart Asset Lab at the Center of Applied AI.
That's correct.
Are you excited for today?
Yeah, I'm really excited to be here today. Open source, all these subjects, all interesting for research, because research is all about open source, of course.
Yeah. And we've got a great program lined up for you today. We're going to hear about building data pipelines at Funda. We're going to hear about the up-and-coming role of the analytics engineer. We're going to hear about the data build tool and much more. But first, we're going to talk about data science innovations with Rens Dimmendaal and Diederik Greveling. Rens, you're a data scientist at GoData-driven. And Diederik, you're a machine learning engineer at GoData-driven. So, Rens, Diederik, welcome.
Thank you.
Yeah, so innovations in data science. Let's talk about recent innovations in data science, indeed. The first subject, transfer learning. Could you tell me a little bit more about what it is? Many people may have known about it, have seen about it, Van Goghs and the monads, but what is it?
Yeah, so transfer learning as a technique came about 10 years ago in computer vision. And the trick is basically that you train a model on one data set and then use it as a starting point to use on a smaller data set. So in the picture over there, you see that the top model is trained on a huge image classification task, but then the learned weights are transferred to a smaller data set task where you do image segmentation for MRI. And this transferring is useful because for the one case, you have a lot of data, and the other case, you have only a little bit of data. And then you get better results on that small data set.
Very interesting, Rens. And could you tell me more about it, about the origin and the...
Yeah, sure. So the difficulty is gathering data. And so for image recognition, the breakthrough moment was ImageNet, which is a huge data set where they painstakingly classified all these images so they could use them. And this is so in computer vision right now, it's default to basically do transfer learning. This is nothing special anymore. But in other fields, transfer learning is a much more recent phenomenon. For example, in natural language processing, over there, nobody did this huge labeling exercise basically to make a nice labeled data set. But more recently, let's say 2 years ago, 3 years ago, people started to figure out, hey, we can actually do a different type of transfer learning there. And that's with masked language modeling.
Yeah. So, and what do you see currently in these NLP systems used as algorithms?
So algorithms used, for example, are BERT or GPT-2 and 3 nowadays. And the key thing that's interesting about them is that you can just use them with unlabeled data, because what the task that you do with them is basically you mask out a word, and then you try to predict the missing word in a sentence.
Yeah.
And and that's now in NLP. That's in the last 2 years. And now this idea is also transferring to other domains, for example, to protein engineering, where data is even more scarce.
So that's what we're talking about this today. About the current developments in these systems, the algorithms.
Yeah, sure. So in different domains, basically, you see that you can get advancement if you have more data, because then you can make a better model, then you can make a better product, you can get more customers. But domains where gathering data is very expensive and hard, so for example in protein engineering, where you really need to make stuff in the lab, it really helps if you can kickstart that with external data. And that external data can then be public data sets that are just publicly available because researchers gather them and make them available to the world, but also inside your company. So if you've done previous experiments and can use that data as a starting point for your next experiment. And these types of things are really empowered by the technique of transfer learning.
So you see that the fundamental ideas of transfer learning from the Van Goghs are now currently applied into your business?
Yeah, basically, and it goes to protein engineering, but also goes to text, to sound. It's a concept, and you can apply it in many different domains.
Yeah. So where are we now, and where are we heading to in the near future?
Yeah, that's a good question. I think so. Continuing, let's say, on the picture that we now have here as well. It's that if you want to do this well, the trick is to really be able to connect with subject matter experts to know what data you should be using to do transfer learning. Because, there is all this data, but what data should we use? And on the second hand, you also have this engineering problem of how can we actually make these models that have this match of different data sets that all need to be transferred. That's something different than starting with just your single data set and doing a model. Then you need to know, okay, what should I use as a starting point? And that's also an engineering question in bigger companies.
So we're doing the transfer of the transfer learning in this case?
Yeah, deciding what to transfer. Yeah.
Very, very, very interesting. So let's go into the next subject.
Excellent. I'm looking forward to it. Diederik, you're going to talk to us about the backtesting as a framework.
Correct. Yeah, indeed. The product is called Backtesting as a Service, BaaS. But before we go into that, we have to explain a little bit what is backtesting, right? So nowadays, the stock market mainly is being done digital, right? So that means that whenever a stock is bought or sold, it's basically being done in a digital way, and that of course generates data. Now, it turns out that if you can do this in a digital way, then you can also basically trade automatically. So you can create systems which automatically, trade stocks and thus are trying to create a profit. This is called algorithmic trading strategies. And what you actually want to do whenever you generate a trading strategy like this, or you create one, you would actually want to test how well it did in the history. So basically saying, what if I put my trading strategy into production 2 years ago? For this, you would test on historical data from the stock markets, and this process is called backtesting.
So you're looking back at the history to innovate the future.
Well, exactly. Yeah. You can see it like that. Yeah, definitely.
So, but that may be a bottleneck in this issue, I guess, isn't it?
That is definitely true. So, of course, these trades on the stock market, they are executed like millions of times per day, and this, of course, generates a lot of data. So, say I create a trading strategy that, for example, trades on 1,000 stocks. I would like to have, 100 features per stock. I want to test it over the last 10 years. We are really talking about terabytes of data over here. And this, of course, is a challenge to process. And we are seeing that running a backtest can sometimes take more than 24 hours in order to complete it.
So compute time is really the bottleneck in this case.
Yeah, definitely. There's also another thing where basically all of this data is time series data, and that's generally a little bit harder to execute in parallel. But it's mainly the scale of the data and the amount of data that you need to process.
Yeah. So how can we speed this process up? I mean, you've got a framework, isn't it?
That is true, definitely. So what we're seeing, especially in the data science and data engineering world, is that we have been trying to solve these issues. So with the rise of distributed computing, where we basically say, well, we try to split up a problem and then just execute it on multiple, let's say, machines, as well as with the rise of the cloud, where we're basically getting compute rather easily, where before you need to invest millions in a large data center. Nowadays, I can create an account with any of the cloud providers and get 1,000 machines in mere minutes if I'm willing to pay for it, of course. This makes that these problems can actually be solved, also for large backtests.
But you have to make wise decisions, isn't it? You cannot scale up until the end of times in extreme parallel.
Of course, there is of course an upper limit to that. But what we are seeing is that these problems can actually scale quite well. And so, especially with the projects that we did, we were actually able to get backtests which would normally run in hours back to minutes.
Back to minutes.
Yeah.
Wow, that's very impressive. So the BAS platform, could you tell me something about the BAS platform?
Yeah, so the idea was, so this started with a program called the Moonshot program within GoDataFest. So a colleague of mine and I got the chance to work on this for a month full time. And so we created a platform where you can run backtests, which basically abstracts all of this low-level scaling stuff and this low-level processing bit in the cloud stuff away. And so that means that if I would want to run a backtest, I can very easily just run a few lines of code. I can define my data, I can define my features and my training strategy, and the rest is basically done automatically and also quite fast, which of course is what you want, because the faster you get the results, the better.
So we're talking about open source. Is this BAS platform publicly available, for example, for my students?
So we are indeed thinking about this. So we have been using open source technologies like Spark, for example, and Pandas. We are looking into a way where we can maybe open source this. But for now, it's more of a proof of concept where we use open source technologies in order to be able basically to fix these issues of large scale backtests.
Wow, that sounds great, guys. I mean, these are two really good examples of how advances in data science and data engineering translate in new approaches in different subject areas. Rens, Diederik, thank you very much for being here. This has been really, really great. I really enjoyed learning about backtesting as a service. And I mean, I only know transfer learning in terms of images, so it's really good to hear that it has more solutions or solutions in different areas. Thank you very much.
Cool. Thank you for the invite.
Really interesting to see all these developments in open source.
Absolutely. I am really especially impressed that they made this in such a short time as well. The backtesting as a framework. Yeah.
I'm also looking forward about the combination backtesting in combination with the transfer learning. I can imagine having these transfer learning elements on the data set and on the time series as well.
That could be a feature of the entire framework.
Yeah.
Really cool. So our next guest is going to talk about data platforms at Funda.nl. His name is Spiros Kouloumpis, and he is the head of data at Funda. And he has joined us right now. Spiros, welcome.
Yeah.
Good to have you here.
Good to be here. Thank you for having me.
I understood that you started coding when you were 11 years old.
Yeah.
You were sent to a summer camp, or you went there and you got into contact with the computer and you just started coding away.
Yeah, it was love at first sight for me. Apparently, my parents wanted to get rid of me during summer, but since then I've been coding.
Wow!
Yes.
And in what language was your first Hello World?
It was GW Basic back in 1987.
Yeah, GW Basic. Yeah. So, Funda, I mean, everyone knows about Funda, and people are continuously checking housing prices, even within this COVID period. It's one of the national apps, you can say. Could you tell us a bit more about Funda, about your side of Funda, your story?
Yeah, so Funda does not really need introductions for those of us living in the Netherlands, but for those watching from abroad, I can say that Funda is the leading real estate marketplace. So almost all houses that go for sale in the Netherlands are listed there, And I find it very unlikely that anyone that bought a house or considered buying in the past few years did not use Funda as a tool in their house hunting. So it is, according to SimilarWeb and sites that rank platforms, we are one of the top 10 most visited sites in the Netherlands. And what is even more interesting is that we are top 10 of most visited real estate platforms worldwide, which is quite an accomplishment if you take into consideration the size of the country. And when it comes to Funda as an organization, it's a very interesting environment to work for, because we are about 140 employees of about 20 different nationalities, so it's really multicultural. And we are very diverse in terms of age and gender, and especially when it comes to data. As you can imagine, all this huge amount of traffic results in huge data. We have millions of visitors and millions of visits. We have our users produce about 1 billion user interactions every month that we record and analyze. So overall, I can say that Funda is a very interesting organization because it's a great environment to work for. If you're working for data at Funda, it's a great challenge. And also, it makes a huge impact. It's a product that makes huge impact on the people's lives. So it's really great to work at Funda.
So we know Funda now from the point of view of the users and your data. But how important is data for you at Funda?
So data at Funda is taken extremely seriously, and data is very important. One of our fundamentals, which are the core values of Funda, this is how we call our core values, says data drives our decisions. So in essence, what this means is that Funda understands as a business the value that data can bring in. It embraces a data culture, and it encourages data-driven decision-making. And this is actually putting an extra urgency to the work done by our team, the data team, where we realize that we need, to streamline our processes and our data infrastructure.
But founded in 2001, I can imagine you have made several developments regarding your data platforms and modernization of your platforms, isn't it?
Yes. So the first thing I did when I joined Funda last year was to take some time, and together with my team, we tried to analyze our data infrastructure and our data sources and how we're making use of our data. And like you said, since 2001, that Funda Funda started operating at 2001. This is way before cloud, right? So as you can imagine, our jobs are on premises. We have scattered databases. We have Hadoop jobs that we were migrating to Amazon EMR. It was a very decentralized setting. So we had two facts in front of us. First, a decentralized setting, and second, data being very important for Funda, and everyone needing data and to make decisions and needing them quickly. So the first decision we had to make was a quite obvious one. We needed to centralize our data infrastructure. And we started this process by looking what was around for us to use. The first tool we considered was Airflow, and it is a great tool for centralizing your data infrastructure and for building pipelines. The best thing with Airflow is that it allows you to write your code and your workflows using Python in form of DAGs. And this is why it has been adopted by so many teams globally. But as teams start to create more and more data pipelines of different nature, they come to realize some specific problems of Airflow. And so just imagine that you have an Airflow instance that is running a machine learning training that requires computing power, and but you, on the same instance of Airflow, you may also run a simple API call to gather some data, right? So what this means, the two issues of Airflow are, first, that dependencies need to be installed across all workers. So at some point, as you have many pipelines, you will definitely run it. You run a high risk of getting into conflicts, and once you do, they will be very, very hard to overcome. And the second problem with Airflow is that these pipelines will not necessarily have the same computational requirements.
So you needed a kind of a game changer to orchestrate all of these pipelines, isn't it?
Yes, we needed a game changer, and that game changer actually was the introduction of Kubernetes support for Airflow in 2018 and 2019. So they started with the Kubernetes executor, but it was made complete with Kubernetes operator. And what this basically means is that you are now launching your jobs in Kubernetes pods. And the advantages are quite obvious. You no longer need to maintain, your libraries and dependencies across your workers. And the biggest advantage is that your Airflow cluster now gets to be really elastic, because it spins up a pod when it's necessary and cleans it when it's finalized, while in the previous Airflow paradigm, your cluster would either be over-provisioned or under-provisioned. So this is why we decided to base our infrastructure on Airflow running on Kubernetes.
I'm really anxious to see your infrastructure set up at Funda in this case.
Yeah. So this
Walk me through it.
Yes. This is what we built. We built it together with GoDataDriven. It was an advantage for us that when we started considering this infrastructure, Funda was already moving into a Kubernetes setup, and Kubernetes support on Airflow was already mature and reliable. So the main components of this infrastructure is our code repositories on Bitbucket, our Azure Container Registry, and the Kubernetes cluster where Airflow is running on its own pod. And once you make use of its Kubernetes pod operators, it launches new pods for each one of the jobs that you want to perform. And this is basically it. By having Kubernetes running on Airflow, what you actually achieve is to get the best of two worlds. You get really nice ways to orchestrate your workflows by writing Python code and DAGs, and then you leave it to Kubernetes to execute your jobs.
There's not only Kubernetes, of course. There's also your data scientists in this case who have to work with this kind of infrastructure. Mm-hmm. So can you tell me a little bit more about how the data scientists interact with this type of infrastructure?
Yeah. So what is really nice with this infrastructure is that we have a unified way of working, regardless of whether we are building machine learning and data science projects, or we just want to deploy a simple Python script that gets some data from an API. So how we work is that we write our code in our separate repositories, and once we are ready to deploy it into production, we create our pull requests, we merge to our master branch, and then our Bamboo deployment pipelines take over, and they run the test, they build the images and place them on Azure. And so far, our data scientists and everyone who is creating applications, the only thing they need to do is write their own code without worrying about where this is going to run.
Wow.
The next thing they need to do is to go to our repository of Airflow DAGs and create a new DAG. And it's very simple because you will write your Python code, and there you will configure some things like which image to pull from Azure, which version, what command to run. Very basic things, very easy to do things. And the most important thing is to actually configure correctly your tolerations and affinities so that the right kind of pod is launched. Yeah. And once you do that, your application is productionalized.
So you're not only decentralized from a data point of view and an IT point of view, but also from a process point of view.
That's the biggest achievement.
Yeah. So did you need a lot of reskilling and retraining of your data scientists in this case?
Yes. So when we deployed that infrastructure, we ran some workshops, and we explained through examples how people can work with it. But like you said, it's a unified way of working. So you don't need to. You can focus on writing code, and you don't need to figure out logging, monitoring, where it will run, and all these things. And what is also really important here is that the skills required are usually software engineering skills. What I described is a typical software engineering way of deploying things with DevOps and MLOps principles. It's very typical that data engineers already have these skills.
So there's also a focus from data engineering towards more software-like development skills in this case.
Yes, exactly.
Could you explain me how you built your ETL pipelines on these platforms and using these systems?
So it's a great question because you mentioned ETL. We don't do ETL, we do ELT. So I'm going to explain a bit why. Many years ago, when traditional data warehouses couldn't handle and were not very scalable, it made sense for people to do ETL. So you would extract your raw data, you would transform it from the system that extracted them, and then you would load it. You would load them already transformed into your data warehouse. But now we have really great cloud data warehouses like Redshift and BigQuery and Snowflake, and there's no need to do that. So they can handle the load and they scale greatly. So it makes more sense now to follow the ELT paradigm. Yeah. You extract your data, you load your data into the warehouse in the raw format, and then you work with SQL usually to transform them into reusable models. So this is the approach we take at Funda. We take an ELT approach. And nowadays, when you're talking about ELT, you don't have to worry much about the extraction and loading part of your data, because there are so many tools around, data loaders, that just do that for you. They make sure that your raw data end up into your data warehouse. And then this shifts the focus of your team to the transformation part. So this is what we decided to do at Funda, and we tried to find a tool and a framework that would allow us to write our SQL for our transformations using software engineering principles. And we had requirements like having different development environments on BigQuery, acceptance and production, of course, version control, running tests. We had our own set of requirements. So we searched for that tool, and we came across DBT. DBT is an open source framework that, in theory, meets all our requirements and even surpasses them. So we thought we could give it a try. We set it up, and we started a DBT sprint. Now, by the end of that sprint, we were able to use our Azure infrastructure with Airflow and Kubernetes, and had already productionalized our first DBT models. And most importantly, we had already loved DBT because of its great features. It actually streamlines the transformation part of your ELT jobs.
And the computational power you required to do so?
The computational power was not an issue because BigQuery does it for you, because all your SQL still runs on BigQuery. If I can tell you a bit about what we really liked about DBT, so DBT allowed us to set up different development environments for each one of the developers working on BigQuery, and that's great. DBT has features that make it really easy for you to write code, and the best features are its Jinja templating, where you can actually treat SQL as functional programming. You have for loops, you have if statements. It's great. And also with macros, you can actually make templates of your SQL scripts or parts of your scripts and reuse them as necessary. And the best example I can give you is how we were able to transform a table that had 2 dimensions and 2 metrics to a pivot version of it with 1 dimension and more than 100 metrics with just, I would say, 5 to 10 lines of code. So DBT gives you all that functionality that you need. And even more, you can run tests on it, you can test how fresh your raw data is, you can test the quality of the produced models. If you're not happy with the building tests, you can even write your own tests, and they are very easy to integrate. And that's really amazing. I highly recommend DBT to any data team trying to figure out how to do the T part of the realties.
That sounds great. So assuming that you're not done yet, what are some next steps?
Yeah, we're not done yet. We consider ourselves fully operational, but we have a lot to do. So, like I described, we created a centralized infrastructure, but we still have a lot of our legacy apps running elsewhere. So the first thing we need to do is to do a lot of migrations. Secondly, we need to work on creating a data lake on Azure, especially for data science projects that require a big amount of data. So it doesn't make sense, and these applications will not be efficient if they have to query BigQuery on Google and they run on Azure. So we will create data lakes on Azure, and we will also avoid this way the extra costs of moving data between clouds. And last but not least, we need to keep adding value for our internal stakeholders and users of Funda, which in fact means more and more, building more and more applications. So we're not done. We have a lot of work to do still, and what I can say is that the next year looks very interesting for the data team of Funda.
And it's all open source.
Yeah, it's really great.
Yeah, very impressive. Yeah. Less burden, more centralization of processes, and open source, all in one package.
Yeah, that's correct.
This is a great story. I mean, how you use open source tools to build your data processing pipelines, and how you just modernize your infrastructure using open source tools. This is really excellent. So thank you very much, Spiros, for being here. I've enjoyed your talk a lot, and
thank you for having me. It was a pleasure.
So, thank you so much. 5 lines of coding for 160 KPIs. I mean, in GW basic time, it would be 1,600 lines of code for 2 lines of KPIs in this case. So very, really impressive how technology and open source developments are pushing new innovations and centralization into the world.
Absolutely. So, many companies also struggle with taking machine learning models into production. And there are many hurdles to take. It can be a daunting process. And our next 2 guests that are going to join us via a live stream are here to share their experiences. And joining us now are Melissa Perotti, the advanced analyst at bol.com, and Simon Stiebellehner, machine learning engineer at the customer happiness team at bol.com. Thank you very much. Welcome.
Hey.
So please kick off your story. We're anxious to know more about your ideas.
Yeah, sure. Hi, guys. Nice to be here virtually. And we're very excited to tell you a little bit more on our way of working within bol.com, but mainly within our team customer happiness. So I would say let's kick off. You see our sheets, right?
Yeah, all visible.
Cool, very well. Well, first of all, before we are going to tell you a little bit more about our way of working, let's start a little bit about telling who we are and how we behave as a platform within bol.com. Because bol.com is one of the biggest online platforms within the Netherlands and Belgium. And being a platform means that we make connection between customers and suppliers, where, for instance, an Uber is a platform where drivers and customers come together. Bol.com is a platform where sellers and customers find each other. And for our 11 million customers, we want to create a convenient way of shopping. But for our sellers, it's also important. We have now around 35,000. We want to be the best place to sell. And in order to do so, we need customer feedback. And that feedback is essential to know where we can improve as a platform, but as well where sellers can improve within their organizations. And that's actually where our team steps in. So our team, Customer Happiness, structures the voice of the customer for the entire bol.com platform and its sellers. And we do so by grouping the customer questions into various business processes so that we can see where the customer questions occur and where thus the biggest problems are within our platform or within the sellers' organizations. And to give you a little bit more of a tangible example, we will give actually 2. 1 within the delivery departments and 2 within the sellers. And we will start with the latter one. So checking our sellers. We help sellers to prevent customer questions. As I just mentioned, we have a plenty, 35K, and those sellers could have customer questions, which actually they will not solve, but our customer service department solves. And earlier, the sellers did not know what kind of questions that were. But as of last week, actually, so this is very new, we have a very cool dashboard, and it's online within our sellers platform. And what they see is actually what you guys see over here as well. It shows how many questions occurred the last 28 days. And it also can see on which topics the questions occurred. So for instance, in this example, so you see the light blue area, which is questions which concern article topics. And when they know that, they can actually improve by putting extra product information, for instance, on their product pages, so that hopefully it will lead to lesser customer questions and in the end, of course, happier customers, which also means happier sellers, and of course as well a happier platform. So that's one of our examples. And the second one is on the other side of the organization, and that's the delivery side. As you probably know, we work with multiple transporters to get packages on time in your houses. And when there is a service issue, however, for example, if there is no note in your mailbox or if the delivery guy is very unfriendly, often a lot of customers come and with their question or complaint to us, to bol.com. And earlier, we couldn't get that information back to the transporters. which is of course not very well because then the transporters cannot improve. And for this opportunity, we actually made this dashboard. And it's a little bit small, but what you can see over here is that we've created, well, a lot of insights where customer questions concerning service of the transporters occur, for instance, in which city, or if it occurred on Sunday delivery or on regular delivery. And most important, on what kind of type of service complaint. So for instance, that unfriendly delivery guy, or that there was no notes. And we made this dashboard using a multiple classification model. And this is actually something which we do with machine learning. And we use machine learning for, I think, almost all our projects. And if you want to know more a little bit about what kind of models we use, you can rewatch the talk of our colleagues Federico and Melvin from last Tuesday. But for today, we will explain you more on how we try to be successful in all of our various projects. And we will tell you why we do it like this. And I think it's important to have a little bit more explanation on why we think it's so important to really think about your way of working. And we have 4 reasons why. The first thing is that, as can be read in plenty of documentation, but we can also see in our teams, a remarkable share of machine learning actually stalls the initiatives of them. And this is due to unrealistic expectations. Is the answer to everything, and maybe even more important because of the lack of support and adoption from business. And maybe that's because machine learning is hard, young, and uncertain. We mean with that it is well, compared to classical software engineering, it is a really new profession. And because of this machine learning, we have a lot of data, which is difficult to address. Modeling is also not that easy to do. And a lot of uncertainties occur still. But maybe even more important compared to the machine learning side is the other side of things, which I'm going to address now. And that's actually our new way of working the last couple of months. Because probably all of us work at home, and the most part of this year already. And we do not know how long it will take before our lives get a little bit back more to normal. We do know, however, that working from home becomes more and more the new reality. And with this change, we see actually that this new reality creates higher efficiency, which leads to higher productivity on the short run, which sounds not that bad at all. However, expectations are that on the long run, working from home causes motivational problems. And this is really a big thing. And this is because a lot of people lose connection with the organization and with their team. They have less structure and see fewer results, and also celebrate success way less compared than when we used to work at the office. And because of this, we wanted to, tell you guys about our way of working, because, having less motivation is really something we want to prevent. And we want to motivate not only ourselves, but also our team members. And that's why we've created this way of working, which hopefully creates structure, deliver results, celebrates failures and successes together as a team. And how we do this, Simon will tell you guys all about it now. So Simon, back to you.
Well, thank you, Melissa, for that introduction. And I hope, we hope that you now know a bit about our background and where we as Customer Happiness Data Lab actually come from and how we are embedded in the Bol.com landscape. Well, Melissa has talked a bit about the way of working. At least she's given you a good introduction. But what is it now exactly that we actually do? And what we do is, for all the projects, for all the data-centric projects, and specifically machine learning projects, basically we slice them up into separate phases. So we structure it. And these phases basically take us all the way from the initial idea, from a use case, to a prototype, and to eventually deploying something in production. But well, as you know, that is quite a long way. So this is also one reason why we actually slice up our projects. Each of these phases is basically like a contract that you want to fulfill. For each phase, we define responsible roles, we define specific timelines, we define specific deliverables, and also we assess the quality of these deliverables after each phase. So basically that means after every phase, we check, we have a look, okay, what have we now done? And are we still on track achieving our overall objective? And if we're not on track, well, either we go back, do something again. That can often happen, for example, preparing some data, doing exploratory research, you might find some strange things, you want to go back and prepare the data again. Or if things are successful, we move on towards production. Or if things just really don't look good, also we really want to fail fast as possible and not waste our time and our resources on projects that are just very unlikely to succeed eventually. Right? So this is really why we came up with these 7 phases. But what do these 7 phases concretely mean? And for that reason, we now basically jump into every of these phases for a bit more of a deep dive. In the first phase, well, it's all about really going from an initial idea to a use case definition. And such a use case definition, for that purpose, we created a specific canvas that suits our needs. And in that canvas, we basically note down what problem do we actually want to solve. And also how are we going to measure if we are achieving our objective and what are our KPIs. And then, of course, there is a big planning aspect. When do we think which phase will be delivered? Also, of course, for every project, there must be a business case. So also that canvas includes a business case calculation to actually make sure that we eventually produce value with the project and eventually make our customers actually happier. And then also there are a few technical aspects to consider in it. What data are we probably going to need? What is the complexity associated with actually getting and transforming that data? And this is probably also the most important part, what skills are going to be needed to make this project a success? That could be a machine learning engineer, that could be an advanced analyst, that could be business analysis. Really depending on the phase, we try to pinpoint what skill we need for a specific time in the project. So after that first phase, we have this filled out project canvas. And that canvas can really be seen as a kind of, again, contract between all the parties involved in that project. So that's our team and that's our stakeholders. And bringing all that we've just seen onto one page, make sure that also all the people involved are on the same page, right? So this is really an overview, it's a contract. And after that phase, well, we do not only have that contract, but also formulated business case, objectives, team, roles, and so on. And that really makes us ready to, if we think that pays off to proceed, to go into the next phase. And in that next phase, well, it is all about getting the data. Since now we know what data we probably need, we know who is going to work on what. Typically, a machine learning engineer or data engineer sets out to explore the various data sources that we have at bol.com, and you can imagine that that's quite some, right? So it's all about getting an overview of what data sources are there and how can we actually bring that data together. That could be, for example, connecting customer questions with returns, for instance, to better understand what customer complaints, what customer questions really cause returns. So in that phase, we try to get an initial provisional data dump together, a data set that we can then really start with that we can use to start building models to actually, start our machine learning approaches or our dashboarding approaches, for example. So if we got that data together successfully and we didn't discover any major problems, this enables us to move to the next phase. And in the next phase, that's something that we call feasibility study. Some others might call that exploratory research, but at the very core, it's the same. It's all about checking what we know so far, given our canvas, given our business case, given the data we have now collected. Are we on track actually? Is it feasible what we want to achieve? Do we have the right data now? Is the data quality sufficient? Do we have enough data? And also, given the data that we have and given what we want to achieve, what is actually now the estimated chance of success still? And if we want to proceed, what would be approaches that are feasible and also sensible? Typically, from that feasibility study, you would do a few loops. You probably go back to data preparation, you know, pull together some other sources again, do some additional quality checks. And at some point, hopefully you've gotten it all right. And you know that, well, either it's feasible or it's not feasible, your project that you want to deliver, the modeling approach that you want to do. Well, if it looks good, then it's time to move on to the actual final modeling work. It's all about building a prototype then. And in that prototype phase, that's a very, very important phase. First of all, well, that's actually the first time when you do machine learning that you actually touch something machine learning related. But also, it's the first part in the project where you actually start to deliver value by delivering results, by delivering the first insights. So typically, that could be after 2 to 4 weeks, you should be able to contribute some value in the prototype phase. In that phase, well, it's, as the name already says, it's really not about deploying anything to production. It's all about building a first model, building a first prototype, a baseline, typically an exploratory in an experimental environment, such as a Jupyter notebook, or you know, a small Google Data Studio dashboard, to just prove that what the modeling efforts we want to do actually make sense, and that we are somewhere moving towards, for example, target accuracy of a model that we set. If that looks good, if our baseline is somewhat promising, and we think that given a few weeks more, we actually can achieve the, let's say, accuracy objective that we set, well, then we take the prototype and move on to the next phase, which is about lifting that prototype into a more production-like environment. And that's what we call pilot. It's about building the pilot. So we take what we've done for the prototype and improve it, bring it closer to our overall goal, and also we bring it closer to a production-like environment, meaning, right, we are definitely moving out of a Jupyter notebook, moving into a proper IDE, following proper software engineering standards, ranging from testing to monitoring, and perhaps also automating a few things, automating some pipelines to have data regularly updated and so on. So at the end of the pilot phase, typically what we have is we have a model or a dashboard that fulfills the needs, the requirements that we've defined. Also, it's deployed and testable, not really deployed in production usually, but it should be usable and testable by our end users. This is really at the very core. The pilot should be usable by end users. Once that is achieved, successfully achieved, we take that pilot and actually run it. This actually brings us to phase number 6, our run pilot phase. Here, what we've created so far, our models, our insights that we generated, our dashboards are accessible to our stakeholders fully, and they should and can test these results in a live setting, right? So they can actually use these insights to, steer on different angles and actually implement changes to really contribute value in practice now. During that run pilot phase, for us as a team that delivers these solutions, it's highly important to really check if the assumptions that we've made and the benefits that we calculated offline also hold for a real life setting. So we ask questions such as, is the quality of predictions really sufficient in practice now actually? Or does it differ vastly from what we calculated offline in offline evaluation? Also, we analyze things like, what is the average response time of our model? Is it actually sufficient? Do we need to scale up certain things? Or do we perhaps need to switch our modeling approaches to something that's less resource consuming, more sufficient to the time that we actually have? And most importantly, we do not only look at the technical aspects, but also we talk to the stakeholders and try to understand how often and also how they use the insights generated. Because only that actually enables us to adapt the solutions that we created to eventually create value and to eventually make our customers really happier. Because that's overall what we want to achieve with the solutions that we at the Customer Happiness Data Lab make. Well, after that run pilot phase, we know how our experiment worked out. We know the business value, we know how our stakeholders perceived that solution and working with these insights, and we know what can be improved. If all that looked successful, if things turned out as planned, Then we take it to the last phase, and that really is the last phase, but it's also quite a long and potentially continuous phase. And this is, well, taking your machine learning software or dashboard to production. And this is basically the point where the clouds on your machine learning sky have lifted, have gone away, and now your endeavor, your rocket, your machine learning project is ready to take off. And this means, you know, all the work you do as a team is changing drastically. It's changing from developing something to maintaining something. So you must make sure that once you enter that phase, certain things should be defined. For example, you should know who ensures continuous operation of that software. You know, operational responsibility should be defined. Also, of course, what you have deployed should be production grade, right? So it's you probably need to do a few things on top of the pilot that you developed. You need proper monitoring, not only from a software engineering perspective, but also from a machine learning perspective. You need to be able to identify when your model accuracy deteriorates over time, if that could be the case. Also, you need to think about retraining strategies. When do I need to retrain my models, and how am I going to measure things like feature drifts, for example? You know, all these are things that add, you know, quite some complexity to this phase, but are highly, highly important things to think about. Well, we've gone over all these 7 phases now, and that's a lot. And that sheet is also a lot, but it does summarize a few things, right? It brings it all into one place. With these 7 phases, what we do is we really structure our projects in a way that brings us from use case to prototype to production in a very, very clear way. And that's great. That's really great because that's not only clear for the people working on it, but it's also clear for our stakeholders and allows us to communicate a lot better with our stakeholders. And so they feel a lot more on board, which is a critical thing when it comes to machine learning projects and data-centric projects. That also brings us to our key 4 learnings that we have made since we have been running that structure, since we've been running that 7-phase blueprint. First of all, acknowledge uncertainty. Machine learning has inherent uncertainty, right? By definition, it's typically probabilistic and not deterministic. So there is uncertainty at its very core. And this is also something that you cannot really change. But what you can change are your processes. So make sure that the processes you define, and this is what we tried by splitting it up into 7 phases, our machine learning projects, make sure your processes account for that uncertainty and make sure to spend your time efficiently and fail fast if that is necessary. Second, make sure your timelines are clear and you actually provide clear deliverables to your engineers. It's very hard for data scientists to work on projects where it's, you know, the goal is just to develop a model, right? Because you can spend months, you can spend years, or you can spend, you know, 4 hours on that. It's a big difference. So make sure that you do define concrete timelines and you do define concrete KPIs and deliverables that should be met at certain points in time. That's not only good for communicating progress to your stakeholders, but it also keeps your engineers and data scientists a lot more happy, for sure. And then also onboard your stakeholders as soon as possible, as early as possible. We try to do that already in the first phase when we think about the use case, and also keep them close to development after that. They should be developing a solution with you because only that's how you can ensure that it's also gonna be adopted and running successfully in practice. Finally, well, the 7 phases that you've seen, they work for us at the moment, but it doesn't mean they're gonna work for us in future as well. It doesn't mean that they're gonna work for you. So this means make sure that these 7 phases, that they are something you can depart on, and also it's something that we depart from, but it's something that's also under continuous change. It needs to be adapted to whatever suits your needs.
Simon?
Yes?
I think we can't see you anymore. There's something wrong with the connection. So you are completely
Frozen.
Oh no.
Oh.
Yeah, you're back.
You're back again.
So could you...
Oh, good.
Can you go 2 slides back, maybe?
Can you go 2 slides back and just redo that part for us? Would that be possible?
Yes. Here?
Let me see.
Oh, I can't control the slides, right?
So
I can.
putting it together.
This one?
I think that's okay. Is that okay, Tim? Yes. Okay. So yes, please. So from this slide, could you take it? Could you take it away? Thank you.
Okay. All right. Thank you. So we've gone over all these 7 phases now of our 7-phase blueprint, and well, that was a lot, and also that slide is a lot, right? It's a lot of condensed information on one slide, but it does give a very good overview of that 7-phase blueprint that really takes us from a use case, from an initial idea to a prototype and to production in the end. There are a few learnings that we have taken along the way since we have been working with that approach. And the really 4 key learnings are, first of all, acknowledge uncertainty. Uncertainty is inherent in machine learning since, well, typically it's a probabilistic approach, not deterministic. So uncertainty really is at the very core of machine learning. So this is something you probably cannot change. But what you can change is your processes. So make sure that the processes you employ when developing machine learning solutions and data solutions account for that uncertainty. To make sure that you do not spend too much time on things that are just not going to work out. Make sure you use your time efficiently and fail fast if that is necessary. Second, ensure that you have clear timelines and deliverables for your projects. And that's not only well, good for stakeholder communication, but it is also good for your engineers and data scientists working on your projects. If you tell a data scientist, well, develop a model doing this, he can spend a few hours on it, but he can also spend weeks or months on that. So in order to ensure, delivering something that makes sense and brings you business value, and at the same time also makes the person working on it happy, make sure to actually define concrete deliverables and concrete objectives to enable people to actually work towards it. Then onboard users early. We try to do that in our 7 phases. In the first phase, when actually defining the idea, when defining the use case, stakeholders and end users really are at the very core here. And we try to keep them as close as possible to development also throughout these 7 phases. Eventually, your solution, your model only delivers value if it is actually being used or if the insights of it are going to be used. So if your end users are not going to adopt what you're doing, well then, no matter how good your model is, it's not going to actually deliver value. So bear that in mind. And lastly, the 7 phases that you have seen, well, they are a blueprint. And that blueprint works for us right now, but it doesn't mean it's going to work for us in future. And also doesn't mean it's going to work for you specifically, right? It's a blueprint that needs to be adapted depending on your organization, depending on your team, depending on the projects that you're working on. So these are our 4 key learnings. We would love you to take 3 key points away from that presentation that we summed up in that slide. First of all, it's all about the team, right? I just mentioned that 7-phase blueprint is something that works for us right now. It doesn't mean it works for you. Create a way of working that suits your team, that's built around your team and where your team really feels comfortable working with and where you can actually achieve the results that you want to achieve. Second, time. Doing such a way of working, defining it is not a one-off thing. You develop it once, but then you continuously need to monitor it, improve it, change it, again, depending on how your team changes, how your projects change, and how the organization around you changes. It's not a one-off task. And third, structure. We slice up our projects in 7 phases, and each of these phases is one step in that project, and each step adds an increment to the overall deliverable of that project. And that structure is really, really good for communicating with stakeholders, and also it provides motivation to engineers working on it because it really breaks down the deliverables into very small parts. And overall, that really makes happy project teams, that makes successful project teams as well. So finally, we've told you a lot about how we try to make our machine learning and data projects lift off. And well, hopefully that presentation has also helped you a bit to make your teams, lift off or lift off even faster. Thank you very much.
So Simon and Melissa, thank you very much. I certainly have learned a lot, and thanks for your presentation.
Yeah, super presentation, very interesting indeed. What I'm wondering, you're the largest e-commerce platform in the Netherlands, but there's a lot of small companies in the Netherlands as well. Do you have specific recommendations for them to implement such a refined process with probably skipping steps or any other recommendations?
You want to answer that, Simon, or shall I?
Yeah, I can go ahead. So definitely, so these 7 phases, depending on the size of your project, 7 phases might sound a lot, and maybe it is too much overhead for you. That really depends on the size of your team, and it also depends on the size of the project. So a recommendation to smaller project teams or smaller machine learning projects is, well, sit down and define really the core phases, and then see if you need more. So start small. Start by defining 2 phases. Could be one exploratory phase and one prototyping phase. And once you have that prototype done, well, then think about how you can move on. So really start developing your process small, and then add to it if you need more complexity in that process.
Yeah, and maybe to add on that is that we are a large company, but our team is not that big concerning machine learning power. So we as a team are also small, and we work like this. So we make a lot of prototypes, and as you see in the examples, we make a lot of dashboarding. And I also can imagine that other teams make software or make various apps or APIs in which they need to put in their models. I then think that maybe the prototype phase is a little bit less important, and you need to go to your pilot or experimental surroundings way faster. So I think as well we've put some timing on each step, that you also need to check which timeframes you think are necessary per step for your particular product, your particular team.
Simon, Melissa, thank you very much for this presentation, and it was great. Thanks.
Thank you.
Yeah, no problem. Nice to be here, guys. Enjoy.
Great to have you. So,
yeah,
until now, we've heard some really exciting stories from our guests. We've talked about innovations in data science like transfer learning and backtesting as a service. We've heard from Spiros how Funda leverages open source tools to manage their data, and how we can bring machine learning models into production just now from Simon and Melissa. But as you should know by now, our own GoDataFest band has been working hard on the GoDataFest song. Today is their last day of practice, and the complete song will be played at the end of this episode. But for now, let's have a sneak peek and see how they're doing. That sounds great.
Yeah,
what did you think?
Indeed, great.
But it's not finished yet, right?
No, and there should be at least some artificial intelligence or algorithms in it.
This was a very analog show.
This is analog. We're going for digital.
Right. So in the second half of this session, and later this afternoon, we're going to talk about how to translate data science into successful business practices. We're going to talk about the up-and-coming role of the analytics engineer, and we're going to talk about the data build tool. But first, Jurjen, I turn to you.
Yeah.
Because you're not just a co-host today. You're also a guest.
Thank you. Yeah, I'm a presenter as well, indeed.
So what is, you're going to talk to us about smart asset allocation?
No, smart asset management.
Yes.
Yeah, data-driven smart asset management we're going to talk about, indeed.
So what is this?
What is it? Yeah, good question. So what you see in asset management, of course, is asset management as is is about making decisions about assets, machinery, fleets, vehicles, buildings, and we in our Smart Asset Management Lab are trying to make decisions based on data and algorithms, and making better decisions as you can do with algorithms indeed.
Great. So, you're doing this at the Smart Asset Management Lab. You just mentioned it. So what is this, and where is it? Where is it located?
Yeah. So the Smart Asset Management Lab is located in the Center of Expertise for Applied AI. And what you see typically in the world of data science is that data science at the academics is typically fundamental. You're making new and improved algorithms for academics from 95% accuracy to 97% of accuracy. But what is really needed in this field of science is that we apply data science, as you have seen in the previous sessions as well. We need to apply data science and make it into production. And that's why we, as the University of Applied Sciences, made a new center of expertise on applying AI systems.
Great.
Really implementing these AI systems. So our Smart Asset Management Lab is part of the Faculty of Technology, Lab of AI.
And that's at the University of Applied Sciences in Amsterdam, right?
Yeah, University of Applied Sciences, indeed, yeah.
So what kind of challenges do you see for small and medium companies regarding starting with smart asset management?
Yeah. So first, good to know is we are located at the engineering department. So we are the collection of all kinds of studies on mechanical engineering, machine building, aviation, mathematics, and all these studies are bundled in our lab. And we're like a physical lab as such. And what we see in practice in our work field is that a lot of companies are struggling on getting the whole chain of data across. There's all these smart asset management and predictive maintenance, for instance, like kind of projects. They start with a machine or a instance of asset that needs to be monitored.
Right.
And you have to imagine, currently there are people walking around in Schiphol, for example, with a pen and a pencil and they're looking at the lamps and say, oh, this is a lamp, is it on or is it off? They cost hundreds of euros per hour for a whole, like Schiphol airport.
Yeah.
And everything is manually. What you need is a whole chain from a equipment and the test.
Yeah.
Through sensors, ETL, data warehousing, to the algorithms, and then making improved decision making. And that's what we focus on, the whole chain of asset management. And a lot of companies have really difficulties to getting these things across.
Right.
For instance, you're having machines in your machinery factory, the data is on USB sticks rather than in the cloud. Or you do not own the data. The data is owned by the vendor from which you leased your equipment,
Right.
which is terrible issue on legislation and all kinds of law and IP.
Yeah.
So getting the data in a streamline from assets to decisions, that's what we focus on indeed.
And so do you make custom software, or do you use off-the-shelf solutions, open source? That's what we're talking about today?
That's a good question indeed. So we are a University of Applied Sciences. We do research. And our research focuses, as I said, on this chain. And we try to help small and medium enterprises in and around Amsterdam to make better decisions on infrastructure. For example, the Kademuren of Amsterdam, a well-known example of smart asset management to be improved, machinery. And what we do is we try to make consortia to do this applied research. For example, you collect a bunch of people, of companies, and you answer specific questions to generate new knowledge. And what we want to do in this case is we want to make a kit that makes it really easy for companies to start measuring. It all starts with collecting data and measuring. So, for example, you got these very simple things as a Raspberry Pi in this case, which cost nearly nothing. And for example, these sensor heads and sensors. Simply a sensor that measures, for example, the vibration of a pump. Allows you to measure the condition of a pump in this case.
Wow.
Or a light sensor allows you to check whether the light is still working.
And the Raspberry Pi is it's an inexpensive, tiny computer basically, so it doesn't really cost anything if you consider the alternative.
Indeed, and it even allows for edge computing, for example, making
Right.
the calculations on the edge instead of pushing it to a cloud interface.
Yeah.
So what we're trying to do is to develop a kit that is available for all kinds of companies to do their research and to do collaborative research on smart asset management and really making AI physical. I mean, this is also AI.
Yeah.
AI is not only in the part of a cloud or part of a invisible e-commerce system. AI is simply measuring something that happens somewhere to make a better decision.
Yeah.
That's what we think applied AI should be in this case.
Great, that's wonderful to hear. And this is what you do at the Smart Allocation Management.
Smart asset management lab.
Asset management. I'm going to get it right by the end.
Get it right.
Smart
Never
Asset
forget.
Management Lab at the university. Excellent.
Yeah. So what you also see, and that's in the figure, we want to make a workshop. So making it physical, not only for the students to be educated on it, but how about doing collective education of companies working on smart asset management, in some cases collaborative with the students to get it done, to get it performed, to get it done.
Wonderful. Thank you very much.
Yeah.
Jurjen.
Looking forward to the future of asset management.
Yeah, me too.
Counting these elements indeed.
Thank you. So this was a really interesting talk, and it fits in really well, right? Because this is all open source.
This is indeed open source. Yeah, we as a university don't want to be connected to a specific type of technology, which makes it indeed fit into the program of today.
Yeah. So we're going to move on. So next, we're going to talk about how companies can successfully translate data science into business practices and how different roles can work together to create a fruitful, innovative atmosphere. And so here to talk to us about this are Mika Nunn and Giovanni Lanzani. So Mika Nunn, welcome. You are the Analytics Academy lead at ING and the program manager of University Partnership at Cumulus Park.
Yep.
Giovanni Lanzani, welcome to you as well.
Thanks.
You are the managing director of the GoData-driven Academy. Welcome to you both. So Mika, what is Cumulus Park?
Yeah, thank you for asking. So Cumulus Park is the innovation district that ING has founded in Amsterdam Southeast.
And you have a video here for us to see as well, right?
Yeah, I have.
So, a short movie about Cumulus Park, but okay, let's talk about the issue itself. Is it being successful with data? Is it an issue at this moment?
Yes, definitely. For many organizations, they sit, of course, on a lot of data. Everybody knows that they need to do something with it. And I think larger organizations already make the first start with it. But especially combining all the data, also bringing together a lot of different data sets from different organizations can bring a wealth of new insights. And that's also what we try to do at Cumulus Park, bringing together different aspects, both from knowledge institutions, universities, but also government organizations, different small and larger corporates, bringing them all together to really think about new solutions. That is the next step in innovation, and that's what we are trying to set up at Cumulus Park at the moment.
So in Cumulus Park, it's a collaboration between public and private companies,
Yes.
which are allocated, which are connected to the system, ecosystem.
Yeah.
Which ones?
Well, we have different ones. So, like I say, smaller and larger. We are just starting up yet, so I cannot really call out a lot of names. But also definitely some of the universities that are also now starting research on specifically on AI. It's very interesting to bring together these insights.
Yeah. Amsterdam is really an AI hotspot at least in the Netherlands, of
Definitely,
course. Yeah,
definitely.
of course. Yeah. So why are these companies struggling? What is your idea about that?
Yeah, like I said, they have a wealth of data, but to know exactly the right use cases, to know what you want to work on is something that companies are struggling with. And I think that's why we're also collaborating a lot with GoDataFest, because we see that organizations need the help from both the business side as well as the data scientists to identify the right use cases for data.
Yeah.
So what you really need is a data and AI strategy.
Definitely, yeah.
So what are the key ingredients of a good strategy?
Well, I think one is setting the right priority, so knowing what the next step is, so knowing which use cases you want to pick on. Then also making sure that you collaborate together with your business leaders in order to set those priorities, know how to identify the data that you have for these type of things. Indeed, well, like you see behind you, knowing that the skills you need in the organization to bring out these right use cases, then collaborating with the business to set the requirements, and also working together to make sure that you can implement them. So if you have a lot of good data scientists, that's really great, but you shouldn't, well, they should not only work on their hobby projects. So definitely working together with business leaders to make sure that you use the right strategy, that you make sure that you take the right use cases and bring them back into the business to drive decisions.
And are these typically questions from smaller companies or also larger companies? Or do you see a mingling between the questions or the tasks asked within these companies?
Yeah, well, I think larger companies are sometimes maybe a step ahead because they have so many good data scientists that they can leverage on. Smaller companies, I think, struggle a little bit more.
Yeah.
So Giovanni, I'd like to move to you. Jurjen?
Yeah, because there's a new role, of course.
There is a new role.
And it has been pushed a lot of times in literature and on the social media. But let's talk about this new role that is existing right now.
Yeah, well, like Mika was saying, that data scientists are important, having the data, but also, I mean, executive support. But on the other hand, it's what kind of use case are we start? What kind of use case are valuable for our company? And we even asked some 700 data professionals last year about how you're getting value out of the AI solutions you are developing. And only 15% of them said, we are actually putting AI solutions developed together with the business in production. That meant that the rest was not doing that.
You may repeat this percentage. For
15%.
15%, huh?
Yes.
We're talking about really small numbers of getting it done.
Yeah, so 85%, it's not getting, in principle, they're not getting any value, right? Because if it's not in production, it's an experiment, which is, is not really adding to the bottom line or the top line of the company.
You do still have the cost, of course.
You still have the cost.
So this analytics translator, tell me more about it, because this may be a solution for even smaller businesses.
Yeah, that's a role that I think McKinsey first wrote about them. And it's basically the role that should sit between the business and the data teams, the data and AI teams. And the translator should bridge those two words by helping identifying use cases that can be implemented, and also to make sure from the business side that they're valuable, that they're really something that the business will do something with them once they're in production. And on the other hand, they liaise with the data teams to make sure it's possible to implement them from a data perspective. Do we have the data? Can we use the data? But also from a technical perspective. I mean, do we have, is the quality high enough? Do we have the right type of modeling? Data scientists that can do the right modelings. And also, who are the end users for these solutions? Are they on board? If it's something for the, for example, to prevent churn, and the people from the call center need to call the people that have a high, a high probability of churning. Are the call center employees on board with it, or do they not want to do things differently than the last 20 years? The translator, again, it's very important there to make sure everyone is in the same, is pointing in the same direction.
Can I rephrase that as, is there anybody who's able to make a better decision within the organization based on the outcomes of data and algorithms?
Yeah, exactly. So who is going to take an action based on the insights coming from the models?
Yeah.
Because without action, there's no value.
So back to ING.
Yeah.
Analytic translators, are they available within?
More and more, I would say. So we started on this journey as ING a bit more than 2 years ago. And indeed, we are identifying thousands of analytics translators in the organization to play exactly the role as Giovanni is saying. We have not accomplished yet the thousands, but we have trained, I think, around 700 now. So that is really great, and they play this important role of making sure that the data products that we develop are being used in the organization.
And do you sense a difference after the deployment of analytics translators within your company?
Definitely, yeah. So it's out of the experimentation box that Giovanni was referring to, and more applied in the organization. What I think is also a very important role is the analytics translators are able to open up the black box and help also our data scientists to understand the business better. So to make the right decisions when they are developing their models.
Yeah. So what are we looking at here? This is the journey for an analytics translator, isn't it?
Yeah, so here what we're looking at, like the 3 phases we found are the most important when developing AI solution. It all starts with the ideation phase, where you have to define very clearly what the business problem is, and to work with the business, really asking the tough question and challenging them and saying, how are you going to use them? How it's going to help? What's like a back of the envelope calculation of what's the value of the solution we're building? And then the next phase is also in the center of the slide. It's about the experimentation phase. So now is the time for data scientists to go look at the data, build models, and really trying to build something of value and a value that can be measured. And once that is done, it's about going to the next phase, which is the industrialization. So maybe in the experimentation phase, a minimum viable product has been built with a proof of value you showed that, there's actual value in it, that end users are using it, and that there's value coming out of it. And now it's the time to, industrialize the solution, so maybe roll it out to more countries, or to more departments, or to more type of users. And so these 3 phases, we saw that they kind of, they take inspiration from the design thinking methodology, from the lean startup, and from agile, because in each of these, there's a different set of skills that are relevant to make the phase a success. And we think the translator should be able to, in all 3 phases, to really add something to the process to help from the inception up until the industrialization.
Great. And you work together with ING to introduce these new concepts and this new role within the organization.
Yes, that's correct. We work together and we help train and reskill people within organization to make them, to empower them to contribute to this.
What kind of people attend these trainings? I mean, I can imagine the financial people without data science knowledge is far too difficult. Typically, the machine learning engineers is too little business, too much business in it. What kind of people follow these courses?
Well, of course, our organization is already quite data savvy, so that's good. But normally they are the business people, actually. So they're the subject matter experts that work very closely in the organization. We have also agile coaches who attend our trainings. We have product owners who attend this. So as ING, we define data fluency as one of our distinctive capabilities. So we make it very clear that this is a skill, a future capability that we expect from every ING employee.
Help me out, data fluency. What is it?
Yeah, so that's the ability to understand, to speak the language of data. So to understand the importance of data, to know what you can do with it, the art of the possible. But also indeed to make data-driven decisions. So understand that an algorithm or a model has outcome and how you interpret that outcome and how you then make decisions based on that. So we expect that from each of our ING employees. And therefore this role as business translator, analytics translator is so important for us. And also it's not unexpected that people can play that role. So these are indeed the business people that we try to reach out to.
Yeah. And is it difficult to get them involved in this kind of project, or are they really eager to and looking forward to get into these courses?
No, I think it's everybody starts recognizing that this is the skill of the future. So it's not that hard to make that clear. So no, we don't have that problem.
Okay, cool. What are the main learnings so far? The outcomes?
Yeah, for us, from our side, we see that one of the learnings is indeed what Mika was just saying. Take the business with you. So it's never about a we versus them, but it's something that you have to do together. So organization that seeks to really achieve something with data and AI, if the business and the data team are not moving together, it's going to be very hard because there's going to be a disconnect, always there, like of an antagonism between the two. Whose merit is this? But you really have to do something together, and we think that this, with this role, it's a key for success. So somebody that comes from the business but understands the data side of the company, that understands what's possible with data science and what's not possible. I hear very often that towards IT, the business has unreasonable asks, so some things that are not possible, and the translator says, this is what's possible with a model. Things like the garbage in, garbage out paradigm. If you don't have the data, or the data is of bad quality, you can never expect, even though if you have the best data scientists, you will never get a good result. So start at the foundation, starts at the data if you want to get good insights out of it.
So it's all about collaboration between types of people.
Yeah.
Back to the Cumulus Park, that's also about collaborative innovation, isn't it?
Definitely, yeah. And that's also where we think this is a skill of the future. So at Cumulus Park, we try to bring together different industries, different type of people, but we also all about upskilling and reskilling of talent. And since this analytics translator is such an important skill for the future, that's also where we partner together with GoDataDriven to offer this also at Cumulus Park as a future skill.
To get it started within these companies.
Get it started within these companies, to inspire each other, to learn from each other, and also there to start the collaboration together.
So why does it work better to do collaborative innovation rather than from the inside of getting consultants, a bunch of consultants from outside into your company?
Well, if you really want to reinvent your organization, we're all moving much more to a platform economy instead of just selling single products. The ecosystem thinking is getting more important. You cannot do that as an organization alone. And you can also not do it if you really want to reinvent yourself, only working together with startups, so a large organization together with a startup. So what we see more and more is that industries need to open up, need to start collaborating to think of new business models. If you want to be that platform economy, you also really have to open up yourself and be able to collaborate. And that's what we are challenging at Cumulus Park.
So are there any takeaways that our viewers should remember specifically?
Yeah, I would say that begin with the end in mind. If you need to set up if you want to get data value out of the data that you have, start asking yourself, what does the end situation look like? And once you know that, kind of work your way back and say, I need the data, but I also need the people with the right skills. I need the technology. So where are they going to do the analysis? And of course, again, to go back to the executive side, support there. You need funding. You need to think about how's the implementation going to look like. So try to begin with the end in mind. So start with a data strategy that enables you to get where you want to be.
Yeah, wonderful. Thank you very much, Mikanan, Giovanni Lanzani. Thank you for being here.
Thank you.
So as we've just heard, there are many roles needed to make successful data products. An up-and-coming role is the analytics engineer. Our next guest will tell us all about this new role, how it differs from existing roles, and what the added value of the analytics engineer is. Here to talk about this are Stijn Tonk, Chief Strategy and Innovation Officer at GoDataFest. Welcome.
Thank you.
And Juan Perafan, you are an analytics consultant.
Correct.
Welcome to you as well.
Thank you.
So let's just dive right in. What is an analytics engineer?
Yeah, so that's a good question. What we see a lot of companies is that, especially when you look into analytics in the business, it's still a big swamp out there of Excel files or SQL files that are kind of tied together, and they try to use it to do all kinds of analysis. And we really see a role for the analytics engineer to kind of drain this swamp and to bring some software engineering to the analytics world and make that more streamlined. So that's what we see that this engineer could achieve.
Right. So another way of saying that is that you want to provide data consumers like analysts with readily accessible, easy to use, and high quality data.
Yes.
Correct.
Yes.
Right.
Yeah.
So how does the analytics engineer achieve this goal?
In order to achieve this goal, and maybe a really good way to understand this role is with the image that we see right here at the moment. For most people, when they want to cook something, it's just a matter of going to the closest Albert Heijn, getting the ingredients, and just cooking them. And many people actually forget that there is way too much behind all of that. There is a really big supply chain that makes sure that ultimately the products are very easy for you to consume. A successful analytics engineer strategy makes sure that your analyst, and in general every data consumer, also forgets that there is a lot of work behind the data that they're analyzing. Essentially, what we do is we take the very difficult things for some analysts, which are the engineering parts, testing the data, the performance, integrations, and all the way to making sure that the joins are correct. And we just lay the information there for people to be as easy to consume as just going to a supermarket and buying ingredients.
So you are basically talking about creating reliable production-grade data workflows that are well documented and...
Correct. And
excellent.
Very well tested and general maintainable.
So why... It's not still not entirely clear to me, but why do I need this new role? Why can't I just hire a data engineer?
Yeah, I think that's a good question. So what we see is that actually an analytics engineer and a data engineer have different a different focus within the data ecosystem. To again fall back to the analogy of the supermarket, think about a big supermarket chain. You have all the local stores, but behind it is a big supply chain. And when we think about the data ecosystem and everything that comes to that, you can kind of compare it with the supply chain. And then when you think about a data engineer, this is kind of the person that builds up the infrastructure for the supply chain. If we think again in the analogy with the supermarket chain, this is the person who builds the warehouses, who makes sure that the producers of all the goods can somehow deliver their goods. They're stored somewhere and they then distributed to the local stores. Where in our analogy, the analyst wants to just walk in and get the data sets that he or she needs and kind of cook the analysis that he or she wants to do.
Right.
So and here the analytics engineer comes in. This is the person that actually uses or kind of operates the supply chain and makes sure that this infrastructure is in place. But now all of these different products, they're distributed to the right store in the right amount with the right price, such that when an analyst comes in, he or she can just get what he or she needs to do the analysis. So they are kind of complementary to each other.
Right.
Indeed, and I also feel that the data engineer and the analytics engineer should know enough about the technical part and the engineering side to make it work. But a key difference is that the analytics engineer should also have some background in analyzing data, should know how it's like to open up something in Excel, in Tableau, in Power BI, and all of these other tools.
So these are things that a data engineer wouldn't touch.
Indeed.
Right.
He has to know more or less the things that people expect when they're analyzing.
Right. So I can also imagine that there are more skills and preferences that differ these two roles. Is there?
Yeah, so I think, of course, the word engineers in there. So the key thing is that they should be great in engineering, but indeed there are different preferences. And for instance, when we look at our data engineers at GoDataDriven, right, we see that there are a couple of tools that they don't really like. And I think you see the picture here of sushi, supermarket sushi. Well, that's not for everyone. Yep. And that is what some of these, the more IT engineering-minded people, they kind of dislike certain tools. For instance, Power BI or Tableau is not always liked because it's a bit less hardcore coding, but also a bit more graphical user interface. And I think these tools are really important. They are there, and the business can really start leveraging. So it's important that we also bring these kind of new tools to the business. Yeah. And I think that is where the analytics engineer comes in. I think analytics engineers may be a bit less picky about that. It should be like really hardcore programming tools, but it can also be just useful tools that generate value to the business.
So this really falls in with the idea that there's increasing room for further specialization in the data domain.
Yeah,
correct.
Yeah, that's certainly. We see that the ecosystem is maturing. Where back in the day it was a lot about these big data infrastructures. It was really hard to roll out and set up. So then you need hardcore engineers that can really build this. Yeah. Then data science and machine learning came onto the scene. So now you see that machine learning engineers have their role in productionalizing all of these models and making sure they really can be used and are built in a sustainable way. And I think analytics engineers another role that has its room around ETLing and more focusing on data analytics, so more the front end of the whole data ecosystem.
Right.
Indeed, we focus around everything that helps data democratization in your organization. Well, you see the other types of engineers, they have generally different goals.
Yeah. So you already touched upon this a little bit, but can you just explain to me why it's so important for my organization to have an analytics engineer?
Yeah, I think it's one thing is really about is to increase the speed of delivery, right? So a lot of companies have invested in these infrastructures. They're working in integrating different data sources, making sure they land on some kind of data lake or a big data platform. But it's still hard for businesses to get really a positive ROI, so return of investment. And the analytics engineer is another role that can help you accelerate. You see this nice picture of Shinkansen over here. It's a piece of high-tech engineering that's running always on time, and it brings you at the place where you want to be really fast. And I think companies they're kind of already looking into this for data science and machine learning. Yeah? So they know maybe need a machine learning engineer, but analytics, it's still, yeah, there's room to improve it, right? And now they have a bunch of all of these Excels and SQL files, and they're not really built in a sustainable way. It slows down the business in doing all of these kind of analysis. Yeah. And I think analytics engineers, yeah, can really bring the software engineering principles to this and make it all more efficient and improve your speed of delivery when it comes to these analysis.
Great. So I can imagine that this is the case for larger companies, but what if I'm a smaller company or a mid-sized company? Would I start out with an analytics engineer? Would I start with a data engineer? How would I choose
It truly depends on your organization.
Right.
If the priority for you is make sure that everybody's able to use the data to make decisions,
yeah,
from the very technical people that can code, but also the people that have like 10 minutes a day and have no technical background, then probably an analytics engineer is a smart choice. I don't think it has to do with the size of the company, but rather on the focus.
Right, that makes sense. So what I gather from you is that the analytics engineer is really the role in the company to bridge the gap between business knowledge and data engineering.
Yeah. So you have the analytics translator that kind of bridges this gap between doing your data science and putting the business in the driver's seat when it comes to that and bridging that gap. And when we think about engineering, we also still see a gap there, and the analytics engineer can bridge that gap between kind of the data needs of the business, analytics needs of the business, and translate that to, okay, what does that mean for my data infrastructure? How do I make sure that I get up to par with my data availability and bridge that gap? Yeah.
Great. I think that brings us to the end of this chat. Stijn, Juan, thank you very much for joining us.
Thank you very much for having us.
Thank you very much for having us.
Yeah.
You're welcome. Next, here to talk about the data build tool at Ahold are Charlotte van der Schoen. You are a data engineer at Ahold. Jelmer Offenberg, a machine learning engineer at Ahold. And of course, Fokko Driesprong, data engineer at GoDataDriven and prolific open source contributor.
Thank you.
Welcome to all of you.
Thank you.
And of course, from the States, we have Jeremy Cohen, Associate Product Manager at Fishtown Analytics. Welcome.
Hello, good morning. It's good to be here. How are you all?
Very good.
So we're here to talk about the data build tool. So Fokko, please take it away.
Yeah, so I think it was a couple of months ago, a colleague of mine, Henk, he started playing with this thing called DBT. He wrote a blog about it, so if you want to try it, you can also go to the GoDataDriven website and try the blog. And during that time, we also tried to combine DBT with Spark as well. This is also how I met Jeremy. I think Jeremy will give a small introduction about DBT for those that don't know. He's working for the company Fishtown Analytics, the main contributor behind, actually I should say the creator of DBT.
Yeah, contributor, maintainer, conspirator, however you want to put it.
Very good.
Yeah, that'd be great. I've got, I think, a couple of slides to run through here. Just to give a 5-minute intro for anyone who is unfamiliar. Yeah, so I've got the who, what, where, why, and how of DBT here. Start off, the who of DBT is a little bit my company and a little bit the folks here who originally built up DBT and built up a lot of the opinionated viewpoint underlying it. But in reality, we're talking about over 2,800, almost 2,900 weekly active projects, companies that we see using DBT in production today. Almost 8,000 members of a Slack community, an open source community of folks who are contributing their expertise around analytics and around the modern data stack. and then hundreds of contributors already, Foco among them, who have made DBT the core technology and also all of this kind of spiraling universe of packages and plugins as good as they've been. As far as the what, because hopefully I've maybe convinced you. Oh, actually, one more bit on who. The folks who use DBT today, so the companies, I know back in the day, we were looking at mostly tech companies, mostly SaaS tools, e-commerce companies, and so we've still got kind of our standard bearers in terms of software companies, GitLab, Canva, Wistia, some of my personal favorites. But we've also seen growing adoption among much bigger organizations, more traditional, who are making their transition toward the modern data stack. So also cities and also airlines and really major organizations in 2020. That's a very new thing for us. And as we grow into the enterprise, we're learning a lot along the way. So as far as what DBT actually is, it's just SQL at the end of the day. It's just an opinionated and extensible framework for writing SQL in a way that needs to be accessible to analysts, but also can be used and leveraged and scaled by some of the folks I'm joined by today, some of the really talented analytics engineers and data engineers. That's really what, at the end of the day, it's not rocket science. It's just a way for us to organize our opinions in our code bases. In terms of where, why, a why or where, what's where? Yeah, okay. It's the modern data stack. It's sitting on top of a modern data warehouse that sits itself in between an extraction layer, maybe a Fivetran, Stitch, Xplenty, one of these off-the-shelf ETL tools that brings data into the warehouse in raw form. It needs to have some opinionated transformations on top of that before it can be fed into the BI layer, fed into machine learning pipelines, whatever downstream uses we have for our data. And in the middle of that layer, there's a whole bunch of steps that are needed beyond just renaming some columns. Yes, it's transforming, but it's also testing and snapshotting and having quality assurance and version control along the way. The why here is to me the most interesting piece, because I've now been at Fishtown for almost 3 years, and so I've been here for at least the majority of the development. It really started in the mid-2010s when the modern data warehouse changed the game and made it possible to have an honest-to-goodness ELT stack, extract and load and then transform in place. Once we realized that we have this super powerful technology at our fingertips, and we realized that as analysts, we actually write code, and that there's a whole assortment of people out there who have made a profession out of writing really good code with testing, with version control, with QA, with development staging, production environment separation. Why can't we do the same thing for analytics? That's really what's underlying the DBT viewpoint, which in turn is what's underlying the software. And in the meantime, we've still got a wide community of users, many in the States originally, but now on most continents. I can only think of one continent we don't have any users. I think it's Antarctica, who are making us constantly re-examine and question the assumptions underlying that viewpoint and underlying that software. And both are getting better as a result. So as far as our last little how, again, it's just SQL, a little bit of Jinja, a little bit of YAML, by creating model files that include business logic, that include that business logic just as select statements. And using this magical ref function, DBT is able to infer dependencies and build out a whole directed acyclic graph of transformations, a whole DAG. And I think I've got, if it works, a fun little animation on the next slide to show that.
It's not running, sorry.
That's okay. Imagine you've added a new ref function and just magically there's a new node in the graph. I think we'll have plenty of time to talk about graphs. I know folks here have a lot to say about that. So I'll yield my time. I've said enough.
Thank you.
Thanks for the introduction, Jeremy. I think you can talk about DBT for days. I can talk about DBT for days, but maybe it's nice to hear about Ahold, who's actually using DBT in their production environment. Maybe Charlotte, how did you get in touch with DBT?
Well, actually, you introduced me to DBT. You used it for another project, and then we implemented it for our project. And it turned out very good. And I think after that, we gave a presentation about it, and then Jelmer also started using it, right?
Yeah, correct. Yes.
And maybe now other people are going to use it.
I think when you joined, we were all not fully DBT yet. Maybe it's nice. Maybe we can go to the next slide. Maybe you can tell something about what we see here.
Yeah, so I started in May at Albert Heijn, and I joined the project with Foucault. That project was already going on for well, I don't know, for a while. So when I started out, it was kind of a puzzle what was already built and how the data flow went. And so I just made a huge data model. I drew it actually on paper, and then I transferred it into something a little more technical. But this data model was outdated after like a few weeks, so it was a huge effort for nothing. And after we used DBT, it has like the DAG function, what Jeremy just explained.
If you can show it on the screen.
Yeah, and now you can just generate your whole data lineage actually with just one click or one sentence, which is very nice. So you can have a nice overview of your data flow.
It's always up to date, right? So
yes.
No lingering documentation on Confluence or someone who wrote something that's already out of the company. So, Jelmer, what was your biggest advantage of DBT, I would say?
Yeah, of course, the lineage graph that we show here, that is really nice to have. But for us also, a big addition was the testing. So we originally started out as with our project writing our data sets in the form of mock data, and this was a very tedious job. But at first, it was doable. So we had a few data sources. We started out. We mocked these data sources. We actually documented these. And all was good, but then as the project continued and scaled up, more sources were added, and we all know how that goes. So maintaining that mock data became very hard to do, and the complexity increases, and you want to take care of all these edge cases that can occur. So we were looking for something that we could use to test on our actual data and develop without having to pull the whole data to a local machine, for instance. And for us, this is where DBT came in. So we can define in a YAML file our data models and the tests we want to do. We can even write our custom implementations. Yeah, and DBT will run these things even in parallel if they are independent. So that was really nice. Yeah.
And what do you mean by parallel then?
So if you look at that DAG picture, some of these data objects, they are independent of others, right? So what we can do with DBT is say, okay, we want to use the concurrency mode, and DBT will submit these jobs to Spark, and we'll run them in parallel.
Okay.
So that speeds up the testing process quite a bit as well.
Yeah.
Yeah.
That's very nice. So instead of like when you have a notebook, everything will run from top to bottom. Here you can actually parallelize and scale out.
Yeah, exactly.
Very nice.
Yeah.
So I know you that you're also like a very, how do you call this? You have like maybe a love relationship with Scala. How did SQL? Now you're instead of you used to do a lot of PySpark.
Yeah.
You tried Scala a bit, and now you're back to SQL. How does that feel?
Yeah, so the Scala love relationship is still in the early days, but the Python one is long-standing. But going back to SQL felt a bit as a step back. But in the end, if you try out all the functionality that DBT offers in some of the plugins, you see that there are only a tiny bit of restrictions there. So for instance, streaming. But on the other hand, the Delta API is fully supported, and that's what we use mostly. So yeah, for me, it was also nice that I can now show my logic actually to end users who understand SQL better than some PySpark code. Yeah, so that's a huge benefit.
Yeah.
Right.
Yeah.
I think we had something very similar, right? We talked to the data architects, and they we showed them the PySpark code, and they said, oh, "What is this?" And then
Yeah, they had no idea.
Yeah, so
We had to translate it to SQL, and then they understood.
I think it's nice to write in a language that the bigger part of the organization understands. Like maybe 0.2% of the people do Scala, 2% do Python, and I think up to 20% maybe can do SQL analyst, and that's very nice.
Yeah.
So do you run the pipeline every time end to end? Or do you have something nice with tags in there?
Yeah. So tags. Yeah, those are a nice little addition to the DBT stack. So what you can do actually is we defined our end-to-end pipeline for the transformations. But what you can do is you can tag specific models with, well, for instance, what we use is the micro-batch tag. But you can name it any way you want, right? We have something that has to run daily or weekly, for instance, store information, which is pretty static. But on the other end, we have sales data coming in, which is refreshed very frequently. So we might want to run just part of that pipeline. And you can do that by just specifying an extra argument with the tag that you would like to run, and DB2 will take care of it. So much of the heavy lifting is taken out of your hands, which is nice. Yeah.
I think that's really cool. Right?
Yeah.
So what would you recommend DBT to other users as well?
Oh, yes, definitely. I really like the testing function. It makes your data more reliable. The data quality is so much better. Yeah, makes you sleep better. The DAG function. I also like the documentation function, that it's inside your project, so you can challenge each other on PR requests if you actually written your documentation, because, well, you keep forgetting it if it's somewhere else.
For me, it's like when you have a well-tested application and you change something and you see some test failing, then you know, okay, I broke something, right? I think it's very similar to the data test. So if you have some data tests in there that that your product number should be unique, and you change your pipeline and you know that something is failing, then that gives some kind of confidence that that you won't have angry managers at your desk the next day because you broke the pipeline, but you're actually in control yourself because you've implemented these tests before.
That you don't keep making the same mistake again.
Exactly. Yeah.
Yeah. So what about the option to use Jinja? You can build these reusable components that you can use throughout your models and refer to. That's something that we also use for our project.
Okay.
It's really nice. Yeah.
What kind of? Can you give an example?
So, for instance, we use all kinds of derivations from dates, let's say, for our project. So date is an integer or days in the future. And normally you would do a date format with some formatting string in there. But now you can just capture this in a single macro and then just use it throughout your project.
Cool.
So it makes it more readable, I guess. Yeah.
It's very nice, the drive principle, right? So don't repeat yourself.
Yeah, exactly.
Yeah. I think before we also had like macros where we can like watermark the incremental ingestion. Yeah.
Yeah.
Yeah, maybe cross post, but I have a Spark Summit talk on this, so I would highly recommend that if you want to get to the technical nitty-gritty details.
Yeah.
And that brings us to the end of today's session and also of the GoDataFest 2020. It's been an amazing week. We've had over 5 days of events, over 50 speakers, and we will be played out by the GoDataFest song. A big thank you to our sponsors, without which we could not have organized this entire week. So thank you to Amazon Web Services, Google Cloud, Microsoft, Databricks, and Xspirit. Thanks to everyone who made this week a success. The organizers, our co-hosts, of course, and our speakers. And of course, thank you for tuning in, and we hope to see you next year.